Okay, so hopefully you can see my screen okay and hear me okay. And I am gonna, great, great. Okay, so I'm just gonna start in as usual with the slides and then a lesson about applications and developing applications using this Shiny framework. Um, so this is, we'll kind of build on some of the stuff we did already. And let's just launch into the slides. Okay, so we're going to talk about what is Shiny, and we're going to create a little default app and the difference between the user interface or UI and the server functions. So you can actually build a Shiny app either as a single file called app.r or split it out into UI.r and server.r. And really fundamental to Shiny applications is this notion of reactivity, which allows you to create web applications without knowing or having to code in HTML and JavaScript. And the Shiny had this notion of reactivity before there was this React framework that Facebook created to handle its reactivity. But it's still quite complicated to code that yourself. So it's kind of remarkable how easy it is to set up a user interface with drop-down lists and slider buttons, and then create arbitrary functions that take that user input and render any kind of output, whether it's a ggplot time series or a leaflet map, etc., and then allow the user to interact with those widgets and refine and create other customized outputs in the application. So this is different than what we've been doing so far, which has really been in R Markdown. And R Markdown, it renders to either an HTML page, which you can then host on any dumb web server, including GitHub with GitHub Pages for free. Whereas Shiny, it allows you to run these back-end server functions, but that means that it needs the Shiny server, which is a whole web server application to run in order to be able to visit that online. So I'll go over the different ways of deploying that, whether it's your own server using the open source Shiny, or using their shinyapps.io, or even using the commercial Connect server is what they're calling it these days. And then we'll, beyond the default application, we'll go into adding functionality like adding inputs like sliders and drop downs by building up from the default Shiny app and then adding a leaflet map as an output type, and then updating to using something called Shiny Dashboard, which offers a different layout than the typical Shiny, and a few more bells and whistles. And then lastly, we'll finish with just comparing with that with some basic R Markdown and especially this other thing, which is kind of interesting, called cross filter. So if you have a very simple table and have data in that table, you can actually accomplish some of that interactivity within HTML. Um, so I showed previously with the report module using the Flex dashboard and then the digraphs and then allowing it to synchronize with time series. And this crosstalk does a similar thing, and it allows some of these little widgets to be able to synchronize with very simple table data. that you might want to use. And I'll show that example that they have on their website for that, which is using a leaflet map to filter it. Yeah, actually this is from an old talk, so I'll uh, I'll show some other example links out to other Shiny apps that I've made. And as far as indicators goes, when you want to have just more user-based input, then Shiny really gives you all the flexibility you should need for allowing users to select, let's say, regions or specific categories of indicators, and then adding all kinds of customized user interactions. So like I said, the fundamental basis of it is this user interface. So you develop this user interface, which is, with this default example, we just have this old faithful geyser data. And this is looking at the frequency of eruptions out of the Old Faithful Geyser in Yellowstone. So this is just one of those data sets that gets provided by in your base R application. And then the slider is the user input that then can drive the binning of this simple histogram plot. And so the UI is setting up the layout for here the title, here we have a slider, and here we have a plot, and that's kind of, it stops there. And then this has an ID of bins that then gets fed into a backend server function, which is responsible for updating this plot. And that's where the magic lies, is Shiny, the framework, and the server then recognizes that, okay, I'm going to listen for any changes to this slider from the user and then update this plot accordingly. And that's that notion of reactivity, that this plot is reactive to this input. This plot output, I should say, is reactive to this slider input. And we'll see that more explicitly. So I would suggest trying this out, and I'll do this too. Really simple. Let's just start with this file, new file, Shiny web app, and I'll switch over to the R3 exercises and do that. So I'm gonna just say, okay, let's just restart. And I'm gonna go File, New File, Shiny web app, and I'm going to call this app-faithful because it's the Old Faithful. And you can either have a single file as app.r, or which is an all-in-one. So it'll create this folder here in your R3 exercises, or you can have it blocked out. So when you're first starting, app.r, having it all in one is kind of useful because you can see the whole thing. And then as your apps get more complex, it can be useful to split it out. So you can track which is doing what as these files get bigger. There's even some other files you can add, like a global.r would get executed before the UI and then the server.r. And that's helpful for loading data sets and packages that you might need. And then you can even have a www folder in there, and you can include custom CSS if you want to style it differently, and other files that maybe you want to have available for download or what have you. So anyway, let's just go with this super simple app to start. So it created this app-faithful, as I can see in my Git pane. And then if I go into that folder, app.faithful, you can see there's just this single .r file. And here is the contents of that file. So there's a lot of comments here in green, and it's all it's doing is loading this library, Shiny, and then Shiny provides these layout UI functions like fluid page, title panel, sidebar layout, and then we have a sidebar panel, and then a main panel. And here's the input, slider input, and then here's the output, plot output, displot. So displot, then if we want to update that, then we would specify an output dollar function inside the server. But let's just run this app and then we'll revisit and get back more into the weeds. So now when I run the app, I can slide this, and you'll notice that this histogram, the number of bins, then changes according to me moving this slider. And that's so I can stop, and I'm just listening on my local machine, and R is then running that server and then making that interface available on my local machine. So it's really two parts. Here's the UI that we are running, and then here is the server. And this displot is being updated here. And here's where the magic is it says, okay, when I render this displot, like I can basically, it's looking for an input. So there's inputs from the UI, and then there's outputs in the server portion. And it's looking for this input. So it's going to make it reactive to that input. So if I just, for instance, just gave it a number like 20, and I ran this app, this isn't doing anything. It's only doing something because I did this, have this input dollar bins. And then one of the other things that's a little tricky about Shiny applications is just debugging. So what's great is when you're in this local kind of environment and able to run the app locally, you can then set a little browser. And browser is basically, it allows you to browse the execution of the code. So now I can set a browser and then run this app. And okay, so it hasn't finished rendering this application. You see the plot isn't there. Because it's browsing, it's stopped at this point in the code. So now I can actually inspect and look at like, okay, well, what is input dollar bins? It's 30. Okay, let's continue. And then that just sets the number of bins here. These are the bins. And then this is just a basic base R hist or histogram function. And I can continue this. And then let's say I change it from 30 to 42. And now I'm inside here. And now let's look at this input bins. And now it's actually 43. But we can, this is a good way, is a very typical way of debugging. Another way might be adding a message. So now we're debugging. So maybe I'll just comment this little browser and I'll add a message like, okay, what is the value of input bins? And then paste this and add that. So now when I run this app, I can see, okay, now I'm giving myself a little heads up, that's what the input is. And then I go back and now I see the updated value. So this is simple, I think, initially to explain, and then it can get rather complicated as you get more interactions that you're trying to capture from the user. So let's see, going back to slides. It's really strange. Now my slides seem to be empty. Let's try this again. Okay. Okay, so we did this basic, we ran the app. Another way to run the app might be to run this line on the command line. So if I look at my current working directory, here I am. So actually to run this app, I would need to use the folder in which it's located, so app-faithful, and that's just another way of running it. And that it just helps to know what the underlying functions are to these little buttons. And that has a whole bunch of options here about the host and the display mode, which we'll talk about later. Okay. So the plot updates in response to that user input, this moving slider. Let me just get some water here. And this is without the comments. This is the code itself. And you'll notice at the end there's a lot of parentheses here. So it's really good to edit this in something like RStudio, an editor that allows you to see where the parentheses enclose. And it's good to indent things. There's a little shortcut to auto indent that I use all the time. I think it's on a Mac, it's Shift-Command-I, because keeping track of where these parentheses closes, I find tends to be my nemesis. So when we look at that UI definition, this slider input has this ID of bins, and then this plot output has this output ID of displot. So on the server side, this is going to be output $displot, and this is going to be input $bins. So here we see that showing up again, output $displot, and then input $bins. So that's the fundamental concept of understanding the reactivity of how this dependency gets automatically built out by the Shiny application when you define that within the function. We can do display mode showcase, which I'll go ahead and do. So I can do this app and go display mode equals showcase. And then what you see now is it'll actually highlight in yellow as it executes, so you can see which part is executing when. So maybe here I might put like a little sleep, assist.sleep, and let's see, this is in, forget, in seconds. So maybe I would sleep for like 1 second or 2 seconds. And so when I run this stop and run this app again, sleeping, oh, whoops. When I run it in showcase, you can actually see the execution. There it is. And then when I change it, you can see that now based on me changing the slider, it highlights in yellow where the execution then is initiated. Right now there's only one output, so it seems fairly obvious, but once you start having a lot of different outputs, it can, the sequence of how things work can get a little confusing. And under the hood, it's interesting, this seems to affect my Google slides when I run the Shiny app. So I'll just reload. So we can also do this thing where we can add React log true, and then do Command F3. So this is a much more advanced thing, and really more just to show you that, maybe I'll turn off the sleep too. And then if I do Command function F3, this is actually what it's doing under the hood, which is building out these dependencies. So if I go back to the beginning of execution, and then I can step through, and it looks at this output displot, and then there's this sort of internal plot object that it needs to generate, and then there is a width and a height that it actually gets from the client. These are just some more variables that you can actually use in your function that are there by default, and then even a pixel ratio. And here's where that input dollar bins. So we're looking at a graph structure that is where the Shiny app is actually building out the dependencies and keeping track of when things update, what needs to then follow. The whole point is really you shouldn't have to worry about this as long as you build things correctly with the interactivity. So there's a lot that it's figuring out for you. Okay, so to deploy apps locally, you can just run this app. You can even run an app directly from GitHub, where again you have that owner repo. You can have a subdirectory too. If you want to have it on a server, meaning making it available to others, in which case they only need a web browser, then you have to host it. So the open source is available for $0, so you can actually install that. I like using Docker, and that's a whole other lesson, if not course, on using Docker. There's a Rocker is the GitHub organization or owner of a bunch of these Dockers. Carl Bodiger is like the main maintainer of that. Pro, that can get expensive, or now it's called Connect. They have discounts for academics and organizations. And then shinyapps.io, they actually give you a lot. They give you 5 apps for whatever 25 active hours means per month. So you can get started for free, and then you can actually just, in RStudio, click a little button to publish it directly, which makes it really easy to deploy. If you need a little bit more, you can add more apps and a beefier machine with more memory and storage. It's fairly minimal to start, so it just ramps up from there. Okay, so now let's add some functionality, and I had created some examples in a different repository, so we're just going to go through those, and we're going to this is a Shiny dashboard layout now, and we can change. This is the earthquakes and the Ring of Fire in the South Pacific. It's another data set that's easily available in R. But you can imagine these could be indicators, and we can toggle between a map and a histogram of those earthquakes as we filter based on magnitude and depth. Yeah, so now I'm just looking at some of these questions. So about how do you go from to product? You know what, maybe I'll answer those. I'll revisit the questions towards the end. So thank you. Keep on peppering the questions, because we could go into a few different directions with them. But I just want to show this basic functionality. So you can go here, click on that, and then all I'm asking you to do in the lesson, which I'll go to, Ooh. Oh, whoops. I called it apps, not applications. Sorry about that. So this is the lesson here in apps. So I think this, oh, that's wrong too. Okay. So I'll fix that real quick. Index is apps and site apps. So I can just knit that. Knit. Mm. Hmm. Well, that's not responding very well. And just use the command line. Oh, oh, okay. So that should update in a second. So yeah, we did this first part and we ran in showcase mode. There's actually a bunch of examples here that come in our package under an examples folder. So this just shows you how to navigate to that and then run those apps directly. And so now we're gonna just download this Shiny intro master zip into our R3 exercises. So gonna show folder in new window in the files pane. There's my R3 exercises. And then this is what I downloaded. And so I'm gonna just put that over here. So this is unzipped, call it apps. And these are some example apps. So to code these individually would take a little bit of time. So I'm hoping that we can just sequence through these apps so we can then see how we're changing things from one to the next. And I'm separating. So the app.r that defines the UI and the server, and then it just runs Shiny app at the bottom. This is now a different configuration where we have the UI.r and the server.r. So now we're separating this out. So we're just looking at one thing at a time. But it's the same thing. It's the same functionality that we saw before. It's just that old faithful geyser data. And now let's build out to something a little bit more involved. First by swapping out this quakes data. So here, now all we're doing is earthquakes off of Fiji. So we're just using a different data set. And here we're using quakes, which you can see is available. And I can do data quakes, I think, to load it locally. And I can look at data that help. and find more about how to find help on data, or just, I think, quakes to see what this is. So we have a latitude, longitude, so we can map it eventually. But we're just getting this data, and we have two sliders here. So let's run this app. Or not two sliders, but two, we have a more elaborate slider where rather than just a single value for the number of bins, we can specify how big an earthquake we want. So a min and max. And then here, so this is the slider input. And then here we have a min and max. And we look at the help on the slider input. We see that the very first argument is this input ID. So that slider underscore mag is what we then use over here to get the minimum value and then the maximum value. So we're getting two values there. And then we're generating histogram based on this filtered data. Okay, so that's this output hist mag is then here, getting updated here. So there's all kinds of little widgets that we can use. This is, you can look at this widget gallery, and there's, besides the sliders, we can have all these other ones. So we can have an action button with arbitrary functions to run on it. We can have a checkbox. We can have choices, a choice group, can files, we can have a calendar, range, like the typical stuff you see on forums on the web. You can basically have all that stuff. So that's just out of the box shiny. There's a lot of other packages that give you even nicer stuff. And so far we did this Quakes mag. So we just swapped out the Quakes data set. And now we're adjusting by a range of magnitude. And then we can add another variable in that Quakes data, like maybe you want to also filter by depth. And then we can make it a leaflet map. And then we can enhance it with more of a dashboard look, which you might want to do for a whole bunch of indicators. And then I'll just talk about, do a step back and just show you how far you can get with crosstalk before you need to use the Shiny app, which would be more flexible. It's really simple data. Okay. So that was the iteration going from the first default faithful dataset to this Quakes dataset. And now let's look at the next iteration here of adding another, adding a little bit more UI. And so now we're just adding a different slider. So we're going to add another input ID, and we're going to filter by depth and a min and max value. So it's basically the same thing here, except we're going to filter on a different value in that Quakes table. Yeah, so we can run this app and see that now we've got these two sliders. So that allows us to limit things. And then we also can change the variable that we want to plot. So we can plot either depth or magnitude based on, like, does it look like the shallowest depths have higher or lower magnitude? First, so you can even just slide this and yeah, and see that, yeah, deeper, yeah, it changes a little bit. So that's the slider. And the other UI element that we introduced there was this select input. So it doesn't matter where we put these inputs in the layout. it can be in the main panel. I could have moved this over into the sidebar layout. This you can rearrange this stuff, and the reactivity comes on the server side, generally speaking. So this is a select input, which is different than a slider input. So the select input gives you that drop-down list, and here are the choices. So we see that that's constructed like this named list. So even though I use mag and depth in the data set, I can make it show up to the user as something with a little bit more text. So we see under the choices of the select input that it's either a list of values directly, or it can be a named list. And the named list then allows us to give something a little bit more user-friendly. But then when we go use the select bar input, here we're actually just selecting that. I could have used like the dplyr select and then input var as another way of doing this. The way it was there before is just more the base R way of selecting a column. So that's selecting the column that's in the dataset Quakes already. So, which we can see if we just type out Quakes. So lat long depth mag. Yeah, okay, so let's just carry on here with the next iteration, which is actually making a map. So I'm going to close this. Now I'm under 04 Quakes map. And now we're introducing a global.r. So this global.r is a great way to load up libraries to start and to set up any data sets. This runs once during the execution and the initialization of your Shiny app. And then we've got the server.r and the UI.r. So with these packages loaded, now this UI.r, so let's just run this app and see what it looks like. Okay, so now we've got a map up top, and we've got this this histogram below based on what we choose here. So we can just look for the big earthquakes and maybe in deep waters, and we can see that, and we can look at depth or magnitude, and we can see the map and the histogram update accordingly. So let's look at how and why that happens. So now we see we've got this sidebar slider input. We have those slider inputs and select input. And then now here we've added a leaflet output map and a plot output. So most of these HTML widgets, and leaflet is an HTML widget. When you look at htmlwidgets.org, they're great because they work in the R console and the viewer pane, in an R Markdown document, and then in Shiny apps. And there's a framework where you can even make your own. And so this, most of these guys, they have a little section. So for instance, if you look at the leaflet help, there's a whole section on Shiny integration. And they usually have it as a leaflet or a leaflet output. It's usually this is the leaflet package, and so it says like a leaflet output. That's usually the Shiny function that you use to place the HTML widget in your user interface. And then in the server side, there's a render, in this case, render leaflet. So we see that here. So there's a leaflet output. So I'm saying, okay, this is where I want that map to show up in the UI. And then on the server side, okay, I want to render the leaflet. And then inside, it's just what you're used to with making any standard leaflet map, except you can add input arguments. So this is actually another new level of understanding Shiny and reactivity, is we're doing something else here that is a reactive function. So the thing is, with that Quakes data set, we and if we look at this app, both of these visualizations, both the map and the histogram, depend on the same data. So just like any lazy programmer, we don't want to do things twice unnecessarily, and it's also faster if we can do things once. So we want to make a function that captures that reactivity, and then Shiny will figure out what it needs to update accordingly. And that's what this reactive function is about. It's saying, okay, I'm going to get the data frame. And you'll notice now that the histogram depends on this getDF, get data frame reactive function that we just created in the server, as well as the leaflet. So we don't need to tell it twice how to grab and filter the data based on the user inputs. We can do that once and then use that reactive function to bake in the reactive dependencies based on that user interaction that we need. So this getDF is now going to filter based on these inputs, these sliders, and then the variable that we select. And here we're going to get this, and it's actually setting up the data frame variable so that we can just use something called var in the histogram that can be flexible depending on which one we choose. And then this is getting the data, and then with leaflet you can add circle markers. So that's just a function that expects latitude and longitude in columns, and then this tilde says, okay, get that from the input data, a column accordingly. So get that, color it red, and make the radius of that circle according to the magnitude, and fill it only half with the color red. And then this is a pop-up. So so this is gluing or making the string based on those columns, mag and depth. And then we can also add a label here. So, and then expand limits is another thing where we can say, okay, just zoom out a little bit based on all of the quakes, so not the filtered data. Okay, so this is rollover showing us the magnitude. And so if I just get to the big stuff, you can see that. So I'm not changing the size, the radius based on the magnitude. I could do that. And then that's the little pop-up window that I created. But I could, oh no, radius is based on magnitude. Yeah. But this is a very small difference. If I wanted to, maybe I might expand this by a factor of, like, exaggerate this to some power of, like, square that you'll see a bigger difference. So you see little ones, big ones, but anyway, something to play with. Okay. So, yeah, this reactive function is another key thing to kind of wrap your head around, so it's giving that data frame back after I've done the filtering, and then we're using that here, and we're using that here, and then making this accordingly. So far this is functional, but it's not slick, that's for sure. So let's move on to the next one, and we'll see how we can build upon this to use a different layout system. So this is Shiny Dashboard, and you can learn more about it over here, Shiny Dashboard. It's its own R package that allows you to give a nicer look, and you can color code boxes and have this little sidebar swing in and out. So let's see what this looks like and go over how this is different. So we still have these slider inputs and we still have this variable drop down. And out of the box, Shiny Dashboard gives you this little hamburger menu that you can expand and collapse. And then we can alternate between the map and the histogram. So that allows you to, this is like a tabbed kind of view of it. And the way that works, not sure why that's there. So here we're loading the data and the packages. We're just calling Q for Quakes. And then here's the UI. This is the main difference. So rather than just a page and a sidebar, we have a dashboard page and a dashboard sidebar. And we have a sidebar menu, and then we can add icons like the map and icons like the bar chart. So this icon function comes with Shiny, and you can use Font Awesome or Glyph icons. These are a whole bunch of really fun icons. There's a free version, and you can search for all kinds of things, like just look for chart, and you can see all these different chart icons. You can look at just the free version and chart-pi, chart-line. So I like chart-line for indicators. So instead of histograms, maybe it's more like chart-line. And we can run that out and you see that chart, that icon just changed. So otherwise, it's actually quite similar. Now there's also here's a couple little tricks. This is kind of some weird JavaScript that automatically resizes the map to be fully vertical. So that's a whole other lesson. I just basically Googled until I found this, and this overrides the existing height. So most modern browsers that works, and also with the histogram. So that's a little trick to add style tags within the body. And then these tab items. So the Shiny Dashboard, the sidebar menu that is selected then makes, so in this case, tab map and tab hist, that's where, according to the body, that's what toggles it to that view. So, and then inside we just have the outputs map and histvar like before. So when we look at the server, this is basically the same server output that we had before. In this case, it's just, there's more pretty labeling with ggplot to get that histogram. And I think this is an old issue with Plotly that has been since fixed. This little fix there. And then this is doing the same thing with the leaflet map. Okay, so that's a quick tour of what I think are some of the most essential features of understanding Shiny applications, the UI, and the server.r. And you can run and play these different apps yourself in your R3 exercises and see what you can do there, maybe even swap out your own data. And then before we wrap, I want to just show you what this crosstalk thing is. So in this lesson, kind of, we talked about these different aspects of filtering and getting the different outputs. And then I just want to talk about this crosstalk thing. So, because you might be able to do what you need to do just with crosstalk. So this is on the R3 train. This is just a R Markdown website. And this code, you know, it uses this crosstalk. And their little example actually has this little app in it on the website. And the way that works is you can set up this shared data. This is its own crosstalk thing. So I can, and then we can set up a filter and, it's a little weird, but I can then select given elements here. I don't know why the boxes are there. But the point is that we can actually do filtering spatially. In this case, for a very simple tabular data set with latitude, longitude. And that is updating just with a simple HTML widget. I haven't, so now that's just this one point. So I don't, this actually looks a little funny, but and try this in its own standalone thing. And then this slider is actually connected to this crosstalk. So I can just filter for the biggest magnitude ones and see those here. I don't know what those white rectangles, what those are there, why those are there, but yeah. So this has limitations based on how much data you have to map, and it's yeah. So if you have a big data set, you wouldn't want to do this because it has to send it all to the browser, and it's actually just your JavaScript on your browser doing the filtering. So there's no server-side requirements. But I thought this was a cool sort of in-between offering. And when you look at the crosstalk, see, this is the better working example on their side where you can see it filtering based on the magnitude. And then we can go just based on just a little simple box can filter as well. And then certain widgets are compatible, like Plotly, Leaflet, the data table. So it's not in common use, but a couple of nice ones are available. And you see the source code here to do that. So yeah, and this is a shared data object. We add a filter slider on that shared data object. And then we set up these bootstrap columns to give it that layout. So this is like a poor man's Shiny app. So that was just the majority of material I wanted to cover, and then as far as what else is out there, there's a lot of resources. There's a great gallery of other apps with the code available, cheat sheets, tutorials, articles, learning about layouts, Bootstrap if you really want to get into it, modal dialogues, uploading files, downloading reports, and Shiny Dashboard. And then these are just a few few apps that I've done over recent years, sighting offshore wind, routing ships around whale hotspots, looking at the hierarchical ocean health index, some competing uses for renewable energy, environmental DNA, Laravel connectivity, interactive infographics is not really a Shiny app actually, and some explorer of Sustainable Development Goals. And there's links to the source code for all these towards the end. But using a leaflet map and then a Plotly graph, and then you can even have these interact with one another. So this is a trade-off plot that you can zoom in environmental space and see where that maps out to you. And then, yeah, similarly here, you can do that stuff. Ocean Health Index. This one is we're doing a reboot of this to generate reports and through the Shiny app. Yeah, these are all the links to the app's links might not be live, but the source code should still work for all these where you can try to run it yourself. So yeah, that's I think that's pretty much what I wanted to cover, and we're at the hour, so this is a great time to go back and revisit those questions. So, and thank you. It looks like people are already helping each other out, which is awesome to see. So I don't know, Kim, if you've been digesting the questions, maybe you can.
Yeah, looks like there's some great stuff in the chat. The first one, how can you bring a Shiny app from a production server to a production server from a local server?
Yeah. So let's see. This has gone through several iterations. The way that I like the most lately is here. Share this. This is so you basically, if you use Docker, then it sets up a port. You'll notice that if I just launch this app, the IP address, this is my local host. I think I might even be able to type localhost, and it goes to the same thing. And then this is the port. So the way it works is when you set up a Shiny server, then it sends it to a port. But then to make that visible to the rest of the world, you have to map that port to some URL. So this is a little recipe that I pasted in the chat to do that, where Caddy actually does this. It's its own web server, and this is all it's doing so it can go I set up RStudio and Shiny, and actually I just call it RStudio because I want to be able to if I look at rstudio.ecoquants.com, then this is on the server, and then oops. Okay, there we go. And here's like here's a little Shiny app. Let's see. So when you install the Shiny server, you put your apps in this folder called Serve Shiny Server. So if I look in this folder, I can see this here. This is this app, and actually, if I look at this, this is what's called a symbolic link. So I can create a symbolic link on a Unix or Mac that points to the actual folder where I store it. And so this is pointing to that location where I keep it on GitHub. And so this is actually going to map now to shiny.ecoquants.com, and then this Goa rare species map. So this is just a little map with some rare species imagery, etc. Or I'm in debug mode, and I open this app up like this locally on the server locally, and this is the analog to working on my desktop, but it's actually on rstudio.com with its own little port reference, so I can debug from that server. So all of that gets set up with this little recipe, and it redirects the, see here you can see shiny points to the local port on that server. And so that's this caddy thing. Sorry, this is kind of a complex set of stuff, but and then really Docker Compose is how you can spin up multiple Docker containers into one. And I've got this build, so RStudio Shiny, I'm just calling it RStudio. And then this is where I'm opening up ports to RStudio 8787 and the Shiny 3838. And then this is what I use for an API plumber. And then I tell Caddy to also manage those ports. And it's very little to spin that whole thing up. And then this other little trick with RStudio and Shiny lately is this rocker. So if you look at github.com rocker, or maybe it's rocker.org, rocker-org, rocker version 2. So this is where we get these geospatial. So this has like the most packages in it, especially spatial stuff. And this is where it's getting Rocker geospatial. So this is a Docker registered image that I can just readily use. And then the other little trick with the way these Rocker things work are you just say run install Shiny server, and it'll then install Shiny server on top of Rocker. And then you can have it install other packages, so it's readily available. So I can even run this locally. I'm not going to do that because it does. I'm on a fairly weak internet connection, and it's going to have to download images. But all the help for this is in the README, and it even talks about how you can spin up your own machine in Docker, or excuse me, in DigitalOcean. Like this one I'm using is $40 a month. It could be $20 a month. And then you log in, and these are the commands that you run to run it. So it's just Docker Compose once you get cloned this thing, and then there's little tricks to setting up the Google domain to point to that IP address of the server that you get going. But that's how you go into production mode with the free software.
Awesome, thanks. The next question is, how do you make sure when making these that you don't have any issues with confidentiality?
Yeah, so as long as you're using the standard widgets, nothing, should be a security compromised situation. And when I'm on here, I had to log in to RStudio. And also this caddy thing I like because it automatically handles the secure socket layer certificate. So you'll notice this has a little lock on it. So I'm not passing insecure passwords when I'm doing it. And then anything on this site, like I think I might even have some, I create something called just a share that's also available on the host. And a lot of times I'll put little passwords and things here. And then in my application, which I generally have on GitHub, I would read lines from a password file that I might need, or anything that I don't want other people to see, I can put outside of GitHub and then I can have the app still read it, and even the code to do that is available publicly, but the actual content, the data, is not. So yeah, that's basically how I handle it. And then, yeah, even on GitHub, you can have secrets and stuff that you store when you run GitHub Actions. So yeah, there's ways of keeping things out of public view.
The next question is it possible to use display mode with a Shiny app built with Flex Dashboard?
Yeah, I think so. Yeah. So Flex Dashboard gave us that other sort of look, and there's an article about using Shiny with Flex Dashboard. So here's a simple example. Here's the source code. So maybe not though, because how does this get run? You save it as an RMD. Maybe not. Yeah, because you don't use the Shiny Run app to run it. So maybe not. Hmm. Yeah.
Hey Ben, this is Marcus. I asked that question. Google told me no. I was wondering if you knew offhand.
Hmm. Yeah. I guess not. So in Google I trust. Yeah, this has a different kind of layout. So it's handling the all within an R markdown, and then it uses this Shiny runtime. So even your UI is kind of, it's more of that in that format of crosstalk that's kind of baked into a single document. But they do use the render. You can use the Shiny functions, but yeah, it's just a little different.
Can you explain the relationship between a local environment and a global environment variable slash list in Shiny? And can you pass an output, XXX calculated values back to the UI for the user to choose? For example, a slider range based on a calculated data.
Ah, okay, yeah, so that gets into that's where things start getting a little bit more complicated. So in that case, what you can do is you can dynamically render the UI, and there's a function for that. So like here, I've got this. We just run this app. Got this magnitude 4 to 6. It's like the maximum extent. But let's say we add we it's let's see, it's Shiny render UI. And this has some other functions, so I have to look at the example. So yeah, here we're just going to say UI output more controls, and then I'll say UI example as my output name, and then I'll set up this guy. So this would be, so maybe I'll have it vary based on this slider mag. So here, slider input, set input label, min is 1, and then let's just say we'll do this. And we'll do it to the max range here. So this is going to dynamically update that input with this, and this is, maybe I even give it a label. That shows that value. Okay, and then this is something else. When you want to combine multiple tags, you can do a tag list when it otherwise would expect just a single tag. And then these are often expressions, so that's why it's got this curly brace, is that we're outputting an expression, not just a, yeah. So that's called more controls, so I need to call this UI example. And let's see if this works. So this is interesting because it needs this slider mag input before it can render that other UI. Argument value is missing with no default. So we might need to do this thing where we require this input slider mag to force that dependency. Argument value. And this is where debugging can get a little tricky. So maybe I just browser here. It's missing some input argument. So let's see. Slider input is input ID is n. It's going to create that. A label is n. Min is 1. That's this. Oh, and then value. What is value? The initial value. So we'll just say 1. Okay, so now that's what I was missing. So let's just try the simpler version. Run this app again. Stop it. Run it. Okay, so now the max mag, you see here it's 6.4. And now it's 5.2. So I just updated that UI based on another UI using that render UI. So as you can imagine, that it can start to do mental backflips, trying to build out the sequence needed of reactivity. And that's where Shiny kind of figures this stuff out for you for the most part. So this is a text box, which looks a little weird. So I could just drop that from that output and just give it that slider input. And I think I don't even need the tag list if it's just one thing. So now I can just do that. So then it's gonna minimize that slider based on the maxed magnitude. Yeah. Yeah, so render UI is your answer there.
Can you delay execution until the user input is collected rather than replotting immediately for each input?
Yeah, so the first step in that would be something like conditional panel. And that's this thing where we can say, like, let's say we don't want to show this render UI unless the magnitude is greater than 5. So it'll disappear if I move this to 5. That's the desired functionality. So we can have things conditional based on other values. And there I can use this conditional in the UI, conditional panel, and this also starts to look a little strange because it's actually a JavaScript expression. So if it has a different sort of syntax where this expression is now, let's say, where the slider mag, input slider mag, gosh, think this is how I would do it. JavaScript might be 0-based indexing, so I think it's actually 1. So where it's greater than 5. So the condition only when, or that slider mag is greater than 5, do I want to show that other little UI example. And so it's showing it now, but then if it's less than 5, it disappears from the UI. So that's where you can have fairly nested, complicated conditions that you then apply to based on what you want to actually show. At least that's one way of doing it. You could have, of course, also, I could have handled this conditional panel with a UI example, is another one. With because I'm dynamically rendering this user interface, I could alternatively say require input slider mag in this case. R is 1 index, so the second element would be 2, not 1. And then I would say greater than 5. So now it's showing it, and then if I do this, see how it disappears now when I'm below 5. So there's different ways of handling that. That render UI is a more advanced feature, but the conditional panel is a little bit more straightforward initially to use. The render UI has the most flexibility for doing stuff later.
The next question is it possible to connect to any database for a Shiny app to load the data from? Are there any limitations to connecting and loading, stuff like that?
Yeah, so there's a great, I think it's like db.rstudio.com is a great thing to use to check out. And there's the thing with Shiny, especially the open source version, it creates a new database connection each time a user hits your app. And it might not do a very good job. Initially, when you connect to it, it might keep that connection, and you might quickly run out of connections to the database. So the answer for this is this pool thing. So this pool package will pool your connections, so it minimizes how many it uses. And here, like if you want to store your password, I would use a read lines function to read it outside of like my GitHub code that I might want to version and make publicly available, but then read it on your server's file system or your local file system, and then the rest can be publicly available. But the other main feature of this is on stop. So when that app stops, it will automatically close the connection. So this is pretty important if you're using a database in a Shiny app and you don't want to overwhelm the database. This pool package handles a lot of that for you. So, okay, hopefully you can hear me. I just got a call interrupting me. Sorry about that.
We can still hear you.
Cool.
It looks like that was the end of the questions. Everything else in the chat is folks helping each other out, so that's awesome to see. Thank you so much to those who are dropping links and all of that. But yeah, I think that's it for questions, unless any more come in the next minute or so.
Yeah, thanks so much for sharing stuff, guys.
There's no further questions. Thanks so much, Ben, and thanks so much, everyone, for joining. I'll grab the chat and drop the recording in the folder once it's done processing.
Okay, great. And then for the next time, and actually maybe as a segue, I'll just mention this. We'll talk about R packages, and this actually, like one of the R packages that I made, I made a Shiny app just to be able to make use of all of the functions in it. And so you can see the Seascapes for Sanctuaries app based on a core set of functions. So these all feed within each other, and building good functions and documenting them makes them reusable for all kinds of purposes in reporting. So I think it's a good way to finish and in describing how to really streamline workflows and then make your stuff reusable by others. Yeah, I think that'll do it. We'll see you next time. Thanks so much for joining, and yeah, we'll talk soon.